This is the doubling growth equation. It represents the amount of time it will take for a value to double, given a particular percentage of growth. The implications can be considerable. Let's look at the derivation. Okay, so x equals some value, could be GDP, whatever. The growth factor is simply a multiplier that's based on a percentage of growth that's based on some timetable. So if it were 3%, then it would be, the growth factor would be 1.03. If it were 2%, it would be 1.02, so on and so forth. Okay, so it's simply an iterative process of multiplying these two values together. What we'll discover is we'll come out with a particular pattern. So if we just continue this process, you'll see the pattern emerge. So we're multiplying the growth factor again, and of course we come out with the growth factor being squared. So we're continuing this process of multiplying the growth factor, and pretty quickly you'll see the pattern emerge, and it becomes obvious that after a while it's just a matter of x to the gf to the n power, the n being the period of time you're talking about based on that percentage. So if we want to know how long it's going to take to double that original x value, here's what we do. So we have x gf to the nth power times 2x. So as you can see, that's a doubling of the original x value. So obviously, the x's will cancel out immediately. You're left with this. Now we want to get that n, so we use our logarithmic rules. E to the gf to the n power equals e to the second power. And then that equals n log gf equals log 2. So then it's just a matter of n equals log 2 over log gf. And there's our formula. And so all we'll need to do is, if we have our growth factor, that is our percentage, then we can get the number of years, number of months, whatever, that it takes to double that original x value. This graph reveals the function, and it is clear that as the percentage increases, the amount of time required for doubling decreases. The U.S. is struggling to climb out of a horrendous recession, and many consider a 3% growth rate to be insufficient. But a 3% growth rate, applied to the equation, produces a doubling in just 23 years. This requires resources to back up the doubling in a completely reciprocal manner. So the question becomes, how long can we continue the doubling?